Hello friends, I am continuing from the previous video that is on topic. The topic is refrigeration and air conditioning. Right. In the previous video, we have seen what you mean by the refrigeration, what are the refrigerants, what are its good properties for the refrigerants. So we will see now some important terms that are used in the refrigeration system here. So what are the important terms are there in the refrigeration system? One is that is the refrigerant effect. Refrigerant, that is effect here. What is this? Refrigerant effect, sometimes it is also called the RE. RE means it is a refrigerant effect here. What is this refrigerant effect here now? Refrigerant material which will absorb the heat from the zone which is to be maintained at a lower temperature when that outside is a higher temperature, right? So now refrigerant effect means how much heat it will remove per unit time. That means what heat removed, it is removed per unit time here now. Heat means usually we are measuring the heat in terms of kilojoule, right? Heat we are measuring in terms of kilojoule. Time if you took in minute here now, per minute here now, how much kilojoule of heat will be removed? It is moving outside that means what the refrigeration space. How much that will be removed per minute? How much it will be removed? Because continuously we have to remove the heat to maintain lower temperature. So therefore this is called as the refrigerant effect or a refrigerant effect, refrigeration effect, refrigerant effect. That means what we can call here. So next one, another one term, this is one term here now. Second term will comes the coefficient of performance. Coefficient of, that is performance here. So coefficient of performance is what here now? COP. It is indicated as COP, coefficient of performance. This coefficient of performance is the ratio of refrigerant effect to the RE, refrigerant effect to the work input. Means what? Refrigerant effect means, as I have already told, how much heat it will be removed per unit area. That is the refrigerant effect. Work input means, as I have told, that to maintain the temperature which is less than the atmospheric temperature, then we have to supply the work to remove the heat from the low temperature zone to the high temperature zone. We are supplying certain external work or external agency means to supply how much work. It's a more quantity. We are supplying more amount of the work here now. We are supplying the work to remove the heat from the low temperature zone to the high temperature zone. To supply that now, how much heat it will remove. That means what here now? This is the effect how much we are getting here now. So therefore, work input it is there here now. How much work? That means what? Out of that, how much heat it will be removed. This is called as the coefficient of performance. This is the ratio of refrigeration effect to the work input. It may be this COP may be here now, may be greater than 1, may be less than 1 also. But greater than 1 is more preferable. That means what? It is greater than 1, it will become that means greater than 1. When this COP is greater than 1 means what? RE is, that is the refrigeration effect is, which is greater than the work input. Here means what? We are supplying some less work, we are getting the effect is more, refrigeration effect is more. So therefore that means what? COP for the very good refrigeration system is always greater than 1. Sometimes it may be less because of inefficiency of, that means what, the refrigeration system. It may come, COP may come less than 1. But whereas efficiency, if you compare, that means what? Efficiency of the refrigerator is COP only, but efficiency means what? Efficiency is always less than 1, means less than 100% here. It is not possible to get 100% or more than 100%, that means what the efficiency. So therefore, efficiency of the refrigeration system is, it is a COP. It's the coefficient of performance here. This is the second term, this is a COP here. And third term here now, this is the third term we are studying. It is a ton of refrigeration. Ton of, it is refrigeration. Yes. Ton of refrigeration. What is this ton of that refrigeration here now? It is a unit. This is the unit of that refrigeration system here now. Ton of refrigeration means the one data we have to remember here now. Ton of 1 ton of refrigeration is equal to 3.5 kilowatt here. 3.5 kilowatt means what? It is 3.5. It is kilojoule per what? Second. Kilowatt means it is a kilojoule per second here. This is also equal to 210 kilojoule per minute. Kilojoule per minute here. 1 ton of refrigeration is equal to 3.5 kilowatt or a kilojoule per second, or else 210 kilojoule per minute here now. What is this here now? The meaning, the definition of this 1 ton of refrigeration is, if the 1 ton of liquid water, 1 ton of water at 0 degree centigrade is there. What? 1 ton of water at 0 degree centigrade, liquid water. If we want to make same 1 ton of water, same at a 0 degree centigrade, to the 1 ton of ice. So next our aim is to convert this 1 ton of, that means what, the water, to the 1 ton of, that means what, ice at 0 degree centigrade only. What? How it will becomes water to ice? We have to remove the heat. That means what? We have to remove, that means what, the heat. Continuously we have to remove the heat here. So continuously we have to remove the heat means per second how much heat has to remove, or else per minute how much heat has to remove. That is called as the 1 ton of refrigeration here now. How much this is there here now? It is 3.5 kilojoule. That much amount of heat, 3.5 kilojoule amount of the heat per second we have to remove, or else 210 kilojoule amount of the heat per minute we have to remove. Then 1 ton of 0 degree centigrade liquid water is converted into 1 ton of that ice at 0 degree centigrade. Ice means solid here now. So this is about 1 ton of refrigeration. Almost all that refrigeration systems are there, and air conditioning systems are there. They are having a unit of ton of refrigeration. Whenever we are buying that refrigeration system or air conditioning system, we are asking, that means what, that system in terms of ton of refrigeration. It purely depends on the quantity, how much we are cooling, how much space we are cooling in case of the air conditioning system. If we have a large space, we want to maintain a temperature which is less than the atmospheric temperature, we need a more ton of, that means what, air conditioning system, AC system. It is there here. That's why this is the unit of the refrigeration system, coefficient of performance, and this is the refrigerant that effect here. So these are the some important terms, that means what that means what we are studying related to that refrigeration system here. So next, in continuation of this, there are some two refrigeration systems we are studying in detail. So what are the refrigeration system? Usually the refrigeration system here, systems are there here. There are two, that means what, the cycle systems or cycle can call refrigeration cycle here. Now how we are maintaining the space temperature which is less than the atmospheric temperature or a lower temperature, and how to make ice making capacity, what we call here ton of refrigeration, amount of heat is removing to make that water into the ice here. You know, ice factories, we are making that ice here. So therefore, so there are, for that mainly we are studying two, that means what, the cycles. One cycle is, it is called as the vapor, that compression cycle. Another one is, it is the vapor absorption cycle here. So these are the two cycles we are studying in detail. The circuit diagrams are there. So in the next video, that means what, I will continue with these two, that means what, the cycles. Thank you. We'll see you in the next video. Thank you very much.